Hello everyone. Today we'll look at the relational database design and hands-on. I believe two different the lecture notes are posted on your Blackboard. So I'm going to go quick the first slide, and then we'll do more about the hands-on. Okay. ER model was introduced in 1976. Peter Chen, when he was in the Harvard PhD students. And after that, he moved to Louisiana State University for several decades. And I think he has been, age-wise retired a long time ago. And then he now joined the Carnegie Mellon University. Not active in teaching, not active in research, but his name is important at Carnegie Mellon University. So ER entity relationship is a good tool to gather the requirements of a real world and analyze the requirements. A great tool. So if we consider the ER diagram of the university example, then university has faculty members which is affiliated with a department. So each university has different rules, right? Some university has a faculty appointed to more than one department. So everything depends on the interpretation and depend on the policy of the real world examples. And also department may include numerous members of faculty. And department also includes students. Yeah, many students. If we consider well, actually, the ER diagram, we have to interpret at one way in this direction and at another way in the reverse directions. Let me do that for you. Each department, when you start from here, then you need to say each department, and then describe about the opponents, the other side, with some cardinality, whether one and only one or more than one, things like that. So each department has many students, right? Then we have, say, here many students. And then from here to department, then we can say each student can be measuring more than one department or only one department. It depends on the policy, right? Let's say one department. Therefore, there is no dual department major allowed. If we consider this relationship again, then each student is enrolled in many classes. That is very normal, right? So many classes. If we interpret this relationship in reverse way, starting from class, then we can say each class can contain many students, right? So it'll, in this case, many-to-many, N-to-M relationships between student and class. So meanwhile, in this case, one-to-many relations. Similarly, each faculty may teach many classes. So we can say many class. And the other way, from class to faculty relationships, we may say each class can be taught by one and only one faculty. Then we can say number one here, so that many to one relations or one to many relationships. Or again, it depends on the situation. Some universities allow a team teaching classes, right? Then you can say each class can be taught by one or more students. If it is the case, then we need to have here many, right? Then many to many relationships. Similarly, as I said, each faculty needs to be affiliated exact one department, and each department may have many faculties. So we have relationship cardinalities maybe filled like this. So first step, what actually the quite of pre-study needs to be before we work on this ER diagram. So lots of interviews, lots of readings of the documentations and everything. And then we have to understand the real world examples clearly. So that we now work on the conceptual design. Conceptual design is going to use a tool or more than one tools, or maybe no tools, only paper and pencil, whichever appropriate, whichever convenient. But in our case, we are working on ER diagram. So this is the ER diagram, entity relationship diagram. So the outcome of a conceptual design is ER diagram. And so if we consider students enroll instructor, then in the more specific ER diagram, then student box has multiple circles. Circle in this case, nothing but an attribute. So students can be described over CWID, name, and major. Instructor can be described over instructor faculty ID and name and department. There's a relationship, right? Enroll, or I would say advise. Okay, let's say advise. So instructor advises the student. The students can be advised by instructor. This advice may be over which year, what semester, right? This year for 2025, students James is advised by Dr. Yoon. Then this is the case, right? So this is the ER diagram. So when you draw ER diagram, you need to also plug all the attributes. Okay, so this ER diagram will be much more complicated. Once you have ER diagram, then you need to convert it to relational database. That process is called the logical design. So outcome of logical design is nothing but schema. Schema is nothing but the description about the relations, right? Description about relations. So for example, student, then student ID, CWID, name, and major. which comes from here, CWID, name, and major. And department, then department name, department ID, and chair. Faculty, faculty ID, name, and affiliations. Class ID, in our case CRN, right? And then title and instructor. Enroll, therefore it expressed which students is enrolled in what class. If you see here, department and faculty, for example. By the way, from this ER diagram, if it is a rectangle, a box will be converted to a relation. Relation in this case is nothing but a table. So we have a department table, faculty table, student table, and class table. Student, department, faculty, and class. Diamond, which is relationships. Affiliate is gone. Major is gone. Teach, that is gone. Enroll, that converted to a table. Right? This converted to a table, like rectangles in any cases. So this is very nicely, when we have enroll, then we need to bring the primary key in the student into here. Therefore, that will be a foreign key. So student ID, which was a primary key in the table students, now we borrow it into a separate table, like enroll here, right? And then CWID is not anymore a primary key here, but it has a special specific role to play, right? We call that foreign key. Oops. What it means is that CWID here at the students, then this CWID on each row, there shouldn't be more than one row of the same CWID. In other words, CWID in the table of students should be unique, right? Primary key, one of the characteristics of a primary key is a uniqueness. And secondly, if we want to enroll as students in a student table, then we need to first issue the CWID number. So with that number, students can be registered in the table called the students. There's a non-null. Null value is not allowed if it is a primary key. Major could be okay with the null value in the student table, right? I wanted to recall when you were a freshman, then initially you do not have any major, right? So the value for this major attribute could be a null, but value to this attribute, CWID, should not be null because it is a primary key. Once we set CWID as primary key, then it should be, right? Okay. But this major, however, let's see here. So department has a department name and department ID and chair here. And then faculty, we now have faculty ID and name and affiliation. If we want to remove this diamond keeps, this is a relationship. This relationship, diamond, keeps somehow relationships between department and faculty. One specific department and one specific faculty should be related through this diamond. If you simply remove these relationships, then we lose that relationships. What is the relationship between department and faculty? Affiliation, right? That relationship should be maintained, should be kept, even if we convert from ER diagram to relational database, logical design. We have to keep it. So which way that we can keep? One way that we can keep here, I want you to think this. Department has multiple attributes, but if I want to keep in one of the attribute in the department, I would say faculty. There's one way, okay? If I say faculty here. Or the other way is here in the faculty table, which is a multiple attributes, right? And one of the attribute there, I would say department. Department. So I want you to think which way is appropriate, which way is which way may create the problem, which way make our database simple. If we put here faculties, let's say some of the department, cyber department. Cyber department has how many faculties? We have about 3 or 4 faculty members, purely cybersecurity, right? Then those 4 faculty members named here in this one attribute value, then this is not a simple atomic value. It is a complex values. You may say, okay, we can contain complex values. That's fine. What if you want to search, say, if a faculty member name John, then give me the department ID where John is affiliated with. But if I have not only John here, but James, Peter, Chris, so many others, then we cannot make a condition, for example, faculty equals John. Faculty is not equals to John here in this case, right? Because faculty is one of those set values. So having that, then you may be able to see later in SQL expression. It's not easy. We cannot express that in simple language, which is called SQL. Rather, I know you guys, some of you are really good coder, then of course in Python language, you can even further manipulate, right? But that is a different story. Right? Model and the database itself is not really simple, right? It requires always the coding involved. That's not what we want. When you create a model, then we need to make our model simple as possible. So if we keep here faculty, that's not a good idea. Then the other way is that, how about we keep here, the faculty has the department names. Then, for example, faculty John, department cyber. Faculty Usman, department cyber. Very, very in simple way, we have one value for each of faculty members. This is very simple, right? Rather than for each of a department, we have multiple values for the faculty, which is no good. So we don't do this way. So department does not have a faculty information, but faculty has affiliation information here, right? Instead, then here, department ID in the department, that is a solid line, solid underline, so that is a primary key. I linked here, from here to affiliation. Then affiliation is a foreign key. If we say foreign key, then we need to identify it. Where that foreign key comes from, we need to put the references. Okay, so references is department's DID. In our hands-on and real data definition language on MySQL, you may be able to see that. Okay, so all others we examined that way. That is the way of converting a logical design. And this logical design has a very, very clear cut of conversion rules, although I explained this more semantic ways, but there is some rule that you can follow. But in design itself is not our major goal, right? So I wanted to think that level. Understanding is better than memorizing the rules. On the other hand, here, students and class, we cannot do like this. Student has, for example, one attribute called the classes registered. Then each class has multiple class numbers appearing for that attribute, which is no good, right? On the other hand, here in class table, let's say class table IASP 525, student, there may be student attribute. Then that attribute should have multiple values, right? In either case, we have multiple values here, multiple values over there. If it is the case, then why don't we have one separate table? That is the reason enroll can be converted to a independent, no, not independent. This table is dependent on students and class. But anyway, separate table. CWID and CID. Okay? And having the foreign key. For example, here, faculty table has a department, which is a foreign key. What is the requirements of foreign key? If it is a foreign key, then foreign key, the value in the foreign key should depend on the value of that attributes which was originally defined, which is a department table. Department ID appearing in faculty table originally defined in the department table. So there is a department ID there. Okay, that is somehow what it is. Then what is the important characteristics there? Important characteristics is if department, first of all, when I enter faculty members, and then there is a department attribute. So I do not know where that faculty is affiliated. So if I say anything that I want to say, I know he's from cybersecurity, so I would say, for example, here, internet attack department. If I say that, then that violates. What that means is that this guy should depend on here. So that department ID first defined in its own original table. Therefore, value of that department ID should be borrowed from here, from the original table to the current table where that attribute will be as a foreign key. So it should be cyber security, not even cyber. Exact same value should appear here. So value here completely depend on the value that was originally defined. Because of that, if that value if that value in the table which originally defines is modified, or if it is deleted, then likely in the faculty table, the same value as a foreign key should be, okay? If it is deleted, same thing here, should be deleted. If it is modified, sure, it should be modified as well. So dependent, okay? Dependencies. And then a word diagram and all others, I want you to consider that for you. I want you to read this, the comparison between relational database, object-oriented database, what is the key issue for that, and any implementation issues, how to resolve that, and if there is no SQL, then what is the example of no SQL? Then we can say that is JSON files, like here. So FID, the value and attribute and value pair appears here. FID 1212 always go together. Attribute name and value. So name and John, affiliate, cyber, book. Then book is nothing but, for example, publication of this guy is a set, another square bracket, right? From here to there. And multiple publication, multiple books. So first book is first curly brace. Second book is second curly brace, which is a dictionary form in Java. And within this curly brace, then we have again attribute and value pair. Title Java, so title Java, there's one pair in the first element. In the second element, title and Python. So title and Python go together. One pair and another pair. So those are our pairs here. So this is a relational database, can be represented in JSON format. Very nicely, seamlessly. Therefore, JSON is a very special form, but very, very secure. Secure, in a way that we don't lose any generosities. Securely carrying over all the information that's available in the relational database to a simple data formats, that is JSON. So more in the pretty printing ways, it'll be written in this way. Okay. And then now we're going to work on here, hands-on. Okay. In this hands-on, we need to start with like this. Okay. So, okay, what we will do is, rather than doing this, I want to make it smaller so that you can. Like this. And then open up terminal. I have a terminal. Okay. And I want to make sure that my SQL is running. So on to system settings, all the way bottom, then there is MySQL. Green lights, which means it is on. 9.4.0, the current version of MySQL. So how can I run it? Actually, I can run it USR local MySQL binary MySQL -u and -p. Oops. What is? I didn't make JUN not yet, right? So root. Okay. So creation of user accounts will come later. So right now, let's simply work on as a root. So the language here should be followed, otherwise, right, you may have difficulties. So if you want to see the list of databases, then the language here is a show databases. Ending with the semicolon. Sorry. Why semicolon? That is because at some point, let's say those who may know the SQL language may understand. For example, in SQL, if you say select name, major, age, from student table, and for example, register table, and if you want to say from, you continue to say, right? From, oh no, not from, where name equals something and age is greater than some other. Of course, this is not the legal SQL statements, but here select from and where we have multiple conditions, and in the from clause and multiple table names, we can continue to this, right? Because this a long statements. And also it allows us to hit return, move to the next line and another next line, next line, next line. So even if I hit enter, it doesn't take it as the completion of that statements. Unless we enter semicolon, then it takes seriously. Oh, from here with the many lines, and then finally semicolon. Therefore, from here entire, that is one SQL statements. It treats that way. So in the database, not only in MySQL, all others, because SQL statements usually requires much longer. So as far as there is a semicolon, then this the SQL optimizer understands. Oh, this is the end of that SQL statements. Now take a look at if it is legal. If it is legal, then I will process it. It's not legal, right? But anyway, so semicolon is needed. Now we need to create database. So let's say language is a create database, and I would say Mercy DB, or I would say 525 DB, and semicolon. Then it creates show databases. Then I have 525 DB here, right? And then I can create a table. And student. Let's see if we have other full list of those. This is not. Okay, so we have to create a student. I would rather bring earlier one so that I have. Okay, here. Maybe this is better. Better to have all of those, right? Student ID. So we can say CWID and type of CWID, I would say integer, right? And then name, you can say varchar, variable character, and then maybe 20 long variable character you can do, or you can say another syntactic sugar, simply say text, whichever convenient. The difference between text and varchar or character is a fixed length. If you say character 15, then your database allocates the size of 15 bytes long, the size fixed. If you have a varchar, then initially that long, maybe 15, but if it go beyond the 15 bytes, then it can double it. So 25 long, double it. So 50 bytes long. And then another 75 bytes long and 100 bytes long. It increase and shrink the way that we specify. However, if we say text, then it allocates the entire, which is not really ideal, right, in your real production system developments. But in our case, we can do it like this, right? Okay, so, and the major. By the way, major should be, major is major is a the foreign key, which means major. The value for major depends on the department. When you say here foreign key major, then it should reference, as it references. If there is no department already defined, then we will have an error, right? So because of that, I need to create department first. Department, then department name. I would say here text, just for a second, then we will know why I am hesitating. In this case, we should not do text but the varchar. Department ID, I would say that is, wait a minute, the primary key. Okay, name text, okay. DID, I would put here text again. This is what I'm saying. If this is a primary key, then it shouldn't be a text. But let's try to use a text, and we learn text value. As I said, it's not really optimal. It's not really a good way for the production systems, but it is handy for syntactic sugar, for prototyping, for faster understanding, like our class. But not always. That's what we want to see. And then chair, also text. But if you say here primary key, I want to keep DID unique in my table. So we have three attributes, name, DID, and chair, plus another specification said primary key, that is a language, and then we should say primary key is DID, and another parenthesis. If I do this, it looks very nice, but we'll have the issue because of we say DID is a primary key. If it is a primary key, then we shouldn't have this type called the text, because this is a syntactic sugar. We need to more precisely enter the right type. So hit enter, then there is, no database select. We should first select database. So where are we going to work on? 525 DB, right? So 525 DB semicolon. Then we choose database, right? Database is changed. Changed means we choose 525. And then back here, create table department, as I said, DID text, and then DID is a primary key. Okay, so this is a right language right now, but still have an issue, and it says the DID is used a key specification. It should be a real accurate type. So I said here DID like cyber, then there is a varchar, and I would say maybe 5. Okay, and hit enter. So instead of DID text, I said DID varchar open and close 5. So size 5 initially, right? Hit enter. So it should work. Works fine, right? So if I want to see the real schema of that department, then another language that you can see here is a describe, because a schema is nothing but the description of a table definitions. So short DSC or describe, and then table department, semicolon, then you can see this. The field department has 3 fields, name, DID, and character. By the way, DID, the type, varchar, size 5, and null, not allowed. That is what I said. A primary key does not allow non-null, and it should be unique. So that is called the primary key, PRI, okay? Okay, after this, then we can create a student. So student CWID. CWID is integer. And name, I would say text. You can do some more text. And major. In this case, type of major should be the same as DID, because major is a foreign key, so we need to refer to the original definition and then table. So major is the DID in the department table. Foreign key. If we want to do, then we have to have this same format of data, because originally it was says varchar 5. Then here also we should say varchar 5, because it should depend. And then we can say primary key. Primary key in this case, CWID. And then foreign key. foreign key is major, right? Major is a foreign key, which is references. Where? References original department. And which one specific? DID. And close another parenthesis and semicolon. Okay, what is the issue here? There's a mutual. So read syntax in your students. What happened? Foreign key. Foreign key. I think syntax issue here. So let's try to see. MySQL. Foreign key references. So what is the issue? CW primary key that and for key major references department DE period 1D ID, right? Create. Oh. You know what? We should say create table. I missed. Create table, students. It works, right? Describe, then student. Then we have CWID. I'll show you here department. So student has a CWID, which is a primary key. Likely department has a DID as a primary key. But this DID and here major, they are mutually dependent. Although this description does not say, but internally this guy already said that, right? So we don't have to worry about it. So you can do all others further, and then I will do insert into, again, if I want to insert a student here, then major maybe, because there is no major, any record of department, if it is not defined the first, then students, none of the students will have the major values because none of those are originally defined. So we better to do department, insert into department first, okay? So when you do that, then we can say name, DID, chair and values, and then accordingly we can say name is a text, so say cyber, and then DID, there's a bar chart which says cyber security. That is the name of that department, and then the ID of that department, say CSEC. And then chair, you can say Usman. Okay, and then semicolon. then it goes into. Similarly, we want to do, say, why we need to do this. This is not needed, right? If we enter it in the same order that was originally defined, say, computer science, and you can say CS department. Narasim, that should work also, right? The reason that we want to spell out the attribute is because some cases we start with the name, chair, and then it's not really in that order, but in the other order. Then we need to say, for example, math department, department chair, I don't know who is now program director, maybe I don't know. You can say who, and then ending with the department ID, say math. Okay, let's enter. Then we say we can do select all from department, enter. I mean department. I want to list all the content of the table department. Then SQL language is a select star from department. Then you can see all of those, right? Likely, for example, if I want to do more, I'll explain that later. Yeah, when you insert student, insert into student, and then student has CWID name and major. So we can say values CWID, that is integer 1111, name, Chris, and major in this case, for example, English. See what happens. If we say this, then it says this database does not give you an error accurately. If this the database gives you an error accurately, then what happens is that from that accurate errors, there is a point, there is a vulnerabilities. Knowing that, then there is a point that we can attack, right? So in this case, it's not really accurate. Accurate is his English should be defined first. So for example, if we do CSEC, there's a code for that, then CSEC is already defined, right? Here, so that we can enter that. Okay. Similarly, for example, that 112 Christine and CSEC. If we want to do more than one, here it's one at a time, right? One record at a time. Then you can do multiple times. Well, some other times, if you want to do, I want to put everything. So for example, 112 and 113, say Oscar and department 2, math, close, and another record, say 222, and Bob, that person is in CS, So multiple of those at once, that's fine too, right? So if I want to see select star from student, then you can see all of those, right? So I wanted to insert those. Basically, this is the homework assignments, all right? So I want you to practice that more on your own at your side, and then I will do further next week. All right.